Good morning, all. Uh, Today we are going to see. Okay, is my screen visible? Is my screen visible? Okay, no issue. So today we sorry, we are going to see few arithmetic circuits from first unit. So we'll start with first circuit. From this is half adder, right? Now adder word is there in so adder word is there in this name of circuit. So what for what reason the circuit is used? Addition, right? So half adder is a logic circuit which is used to add two one-bit number, right? So this half adder is used to add two one-bit numbers, right? So two one-bit numbers are added by using half adder circuit, right? So see, suppose my numbers are A and B. So two numbers, if we consider, that means how many combination? 2 raised to 2, 4 combination. 0, 0, 0, 1, 1, 0, and 1, 1. Right. So for this term is 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0 with carry. Right. So carry we need to consider in this case. So in all other case, carry is not generated, but for 1 plus 1, carry is generated in this half adder circuit. Now, from this, what we need to check is we need to have a circuit. We need to design a circuit by using this truth table. So what we need to use is we need to use this column to design a circuit. When the values are true, that we need to identify in case of sum and in case of carry. So one is treated to be as true. So for sum, the expression is like when it is true, the second row is where the value of sum is true. So A complement B, right? A complement B. In that case, the value is true. Again, for this third row, it is also true, right? So this one is the case. Or A plus B complement, right? In that case also, it is true, right? So what we need to do is, this is our expression for sum. Are you with me, no? तुम्ही आहेत ना माझ्या बरोबर सगळे ऐकताय? ओके. सो आपण अरिथमॅटिक सर्किट्स बघायला लागलोय. फ्रॉम दॅट हाफ ॲडर काय आहे तर वन बीट चे जे ऍडिशन करते दोन नंबर वन बीट चे नंबरचे ऍडिशन करणारं सर्किट आहे. सो ते सर्किट कसं डिझाईन करायचं हे बघतो. आता हा काय आहे ट्रूथ टेबल. सो ट्रूथ टेबलच्या केसमध्ये काय केलं आपण ट्रूथ टेबल दोन बीटचे ऍडिशन त्याचे कॉम्बिनेशन व्हॉट ऑल थिंग्स आर देअर इन सम अँड व्हॉट ऑल थिंग्स आर देअर इन कॅरी. आता ह्याच्यात काय बघितलं आपण हाफ ॲडरचं सर्किट. नाव this is simply exclusive or, right? This statement, right, or this expression is simply exclusive or, right? Now we need to check for carry. When carry is generated if suppose A and B are 1, 1, right? In that case, carry is generated, right? So this is the expression for carry, right? So here, which gate is used? Obviously, XOR, and here AND gate is used, right? So now how to design a circuit for half adder? Those are my inputs A and B, right? So for sum, we need to pass this A and B to exclusive OR, right? This is my sum. And for carry, obviously A and B is given to AND gate. In that case, carry is generated. If both the inputs are 1, in that case, carry is generated. So this is how we can design a circuit by using truth table and expression. And this is your half adder, right? हे समजलं का? हे समजलं का? हाफ adder समजलं का? Okay. Now, next is full adder. So full adder is addition, right? Full adder is addition. Addition in between, addition in the circuit of half adder. Half adder is a circuit where you are actually adding two bits, but carry is not considered in case of half adder. Whereas in full adder, carry is considered, right? Carry is considered, right? So previous additions carry is considered and to inputs, right? So this is my carry, which is from previous addition. Now, there are total 7 combinations. If suppose my inputs are 0, 0 and carry is not there. Inputs are 0, 0 and previous addition carry is there. Right? My inputs are 0, 1, carry is not. Previous addition carry is not there. My inputs are 0, 1, previous addition is present. Again, my inputs are 1, 0, carry is not there. My inputs are 1, 0, carry is from previous addition, right? Again, inputs are 1, 1, carry is not there. Inputs are 1, 1, carry is present over, right? So this is, previous additions carry, right? So what you need to find is sum again and carry. Complete this task. Find out sum and carry. For this, find out sum and carry for this. So this is how addition and rather sum and carry is generated for full adder. Now you need to identify expression, right? Since this is a big task, you can use KMAP as well, right? KMAP for three variables. This is true at this time. This is true. Or carry is true at this time, right? So consider those things, keeping in mind those things, put all those ones in. This is A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, and 1. When it is true, in case of 1, for sum, 1, then for 2, then for 4, then 7, right? So this is how your K-map looks like for full adder sum expression. And you cannot combine or you cannot group any ones here, right? So you simply write the expression directly. A complement B complement C plus A complement B C complement plus A B complement C complement plus A B C. Right? This is the expression for sum. Now we'll try carry. Okay, carry is on for 3. So this is rail for 3. Now 5, 4 and 5. Then 6. 6 is here and 7. Right. So we can have multiple combinations here. Right? So we can group this. Okay. We can group this as well. Can group this as well. Right. Find out the solution. This group is B is common. A change B, C. In this case, C changing A, B. In this case, B changing A is there, C. Right. This is how the expression looks like in case of customer. Okay, let it be. Okay, so next is how to design a circuit on that expression. Expression for sum is A complement BC plus A complement B complement C plus A B C complement plus ABC. This is the expression for sum. And expression sorry, and expression for carry is AB plus AC plus BC. Now we'll try for this is my A complement, and this is my B complement. This is my C complement, right? Now, first is A, first is A complement B, C, right? Then next is A complement B complement C, then A B complement C complement, and third is last is A B and C. So this is how my product terms are there. Those all are sum, right? So this is how the circuit look like for full adder, right? So you can draw the circuit like this for carry as well, right? So I'll give you 2 minutes. Try to draw this circuit for this expression directly. Try to draw the circuit for this expression. Okay, झालं का draw? Draw झालं का? Okay, so next is half subtractor. Half subtractor is sorry, same like your half adder uh, changes subtraction, right? So, two one bit number subtraction is there in sorry, two one bit subtraction is there in half subtractor. You need to find the difference and borrow there, right? So 0, 0, 0, 1, 1, 0 at 1, 1. And for that reason, you need to find a subtraction there, rather difference and borrow, right? The same procedure is like half adder. You need to find truth table, then expressions, then the change for half adder and subtractor circuit is uh, the circuit is same. The minor change is you need to use inverter therein for A's input. Why? You will get the answer when you check the expressions there, right? So this is the circuit for half adder. You also can have full half subtractor. You also can have full subtractor. This is also somewhat same like your full adder, right? So you need to do all those things which you completed for full adder, right? So here also you need to check the combinations for three units, three variables there, and then find out difference and carry, right? So complete this task. You need to complete on your own this half subtractor and full subtractor, right? So till now is it clear? Half adder, half subtractor, full adder, full subtractor. क्लिअर झालं का? तुषार काय नाही कळलं? तुषार तुषार वानखेडे काय नाही कळलं? म्यूट अनम्यूट कर स्वतःला. तुषार वानखेडे काय नाही कळलं? स्वतःला अनम्यूट कर. मला कळेल की काय नाही कळलं. आवाज येत नाही माझा? आवाज येत नाहीये? अरे तुझं कनेक्शन चेक कर. मस्ती करायची असेल तर लेक्चर नका जॉईन करत जाऊ रे. बाकीच्यांना काही प्रॉब्लेम आहे? हाफ ॲडर, फुल ॲडर वगैरे ह्याच्यात काही प्रॉब्लेम आहे का? काही प्रॉब्लेम आहे का?
सबट्रॅक्टिव्हचा पार्ट परत एक्सप्लेन करता का?
एक्सप्लेन नाही तुम्हाला करायचा आहे तो. मी एक्सप्लेनच नाही केला तो.
ओके.
हा तेच सांगितलं. हाफ ॲडर, फुल ॲडर मी सांगितलं. जसं हाफ ॲडर, फुल ॲडर आहे तसंच हाफ सबट्रॅक्टर, फुल सबट्रॅक्टर आहे. 2 बीट साठी आणि प्लस कॅरी जनरेट करतात. ते कसं बॉरो रादर कन्सिडर करतात ते. सो हे तुम्हाला करायचं आहे ना? एक्सप्लेन नाहीच केले मी ते. ओके. हा नेक्स्ट सर्किट, नेक्स्ट अरिथमेटिक सर्किट. for this is multiplexer. Next arithmetic circuit is. आवाज येत नाही आहे माझा. आवाज येतोय का नाही? चॅटवर पडायला लागलं की आवाज येत नाहीये. ब्रेक होतोय का आवाज? ओके, ठीक आहे. Okay, no issues. So next arithmetic circuit is multiplexer. A multiplexer is a combinational circuit. Now, one more thing is combinational and sequential circuit. राईट. आता हे मी नेक्स्ट लेक्चरला एक्सप्लेन करतो. आत्ताचा गोंधळ काय की आता आपल्याला फर्स्ट युनिट संपलंय, पण टाइम बिंग नेक्स्ट युनिट चालू करण्यापेक्षा एखादं सर्किट घेतलेलं काय वाईट, म्हणून हे सर्किट घ्यायला लागले. सो डिफरन्स जे आहे कॉम्बिनेशनल आणि सिक्वेन्शियल वगैरे ते मी नेक्स्ट लेक्चरला सांगतो. टाइम बिंग फक्त लक्षात इतकंच घ्या की हे सर्किट्स आहेत ते सगळे कॉम्बिनेशनल सर्किट्स आहेत. राईट. सो this is also a combinational circuit which actually used to direct multiple inputs to output based on select line. Now, multiplexer is a circuit used to, or its form is like, many input and one output, right? Multiplexer, call it as many input and one output, right? So this is the circuit wherein you have multiple inputs over there, and based on these select lines, right? Based on select line, you will have output, right? So those are inputs. This is basically a multiplexer, or you can say there are so many types, and what you see there on your screen is 4 as to 1 marks, right? So you have there many input. You can say this is I0, I1, I2, and I3 input, right? Now what actually here it does is, see, this is the circuit. It actually selects one of the input from input line and passed it on output line, right? Based on based on those select lines, right? Or this is 1 and this is 0. If suppose my select lines has the input of 0, 0, then it select whatever is there on I0 or first or zeroth input line to output line, right? If suppose my select lines are 0, 1, then whatever is there on first or I1 line is passed to output line. If suppose my inputs are 1, 0, select lines are 1, 0, then whatever there is at the I2 line is passed to output, right? If suppose my input lines are, sorry, select lines are 1, 1, then whatever is there on input line I3 is passed to output, right? So there are so many input lines available. Based on select lines, multiplexer select one of the input line and passed whatever is there on that input line to output line, right? So this is how this combinational circuit works. And the syntax for this, or you can say symbol for this, is like this. Those are input lines. This is output lines. Those are select line, right? So the formula to choose, select lines and input lines are uh, 2 raised to m equal to n, or n equal to 2 raised to m, whereas n is number of input lines, right? And m is number of select lines, right? Number of select lines. So input lines are 4, in that case select lines are 2, right? If my input lines are 8, then in that case my select lines are 3. If suppose the input lines are 16, in that case my select lines are 4, right? So this is how you can consider the select lines and input lines. There are so many types available for this marks, and those types are 2 as to 1 marks, then 4 as to 1 marks, right? Then 8 as to 1 marks, 16 as to 1 marks, 32 as to 1 marks. You can convert those from any type to any type here in multiplexers, right? You can convert those multiplexers as well. So what all advantages of multiplexers are? Those multiplexers are used for reducing complexity, right? Circuit complexity is reduced by using this multiplexer. And for this multiplexer, now ICs are available. Directly ICs are available for multiplexer in digital circuits, right? So you can use those ICs to uh, form your digital circuit, right? So by using this multiplexer, you can have your different digital circuits, right? You can design your different circuits on your own by using the IC of multiplexer, right? So हे multiplexer इथपर्यंत कळलं का? Multiplexer काय आहे? Okay. Now tell me about demultiplexer. Demultiplexer काय असेल? Demultiplexer काय असेल? Demultiplexer. See, demultiplexer is reverse operation. Yes, demultiplexer is reverse operation. One input and many output. Yes, yes, exactly. One input and many output. Sorry. So one data input or data line is present and many outputs are present. And based on again select lines, what to pass on which output line is depend on those select lines, right? So this is input and those are select lines and those are output lines, right? So what to send on which output line is decided by select line. So whatever input is there on select line, based on that input data is passed to output line. So this is the task of demux or demultiplexer. It is exactly a reverse operation of multiplexer. So where it actually used, it is using data distribution. So in other way around, demux is called as data distributor. data distributor, right? So demux is called as data distributor, and what mux is called? Data selector. Keep in mind that mux is called data selector. It actually selects the data and pass it to output line. So mux is called data selector and demux is called data distributor, right? Okay, till now it is clear about mux and demux. Mux demux कळलं का काय आहे? Okay. Decoder. Have you heard this word earlier? Hmm? Decoder. Have you heard about this? Hmm? I decoder. I think you have gone through the concept called encoder and decoder. Hmm? The functionality of decoder is somewhat similar like uh, demultiplexer, but in case of demux, there are many input lines, right? Many input lines and multiple output lines. Suppose n is input line, then 2n are output lines present over there, right? In that case, you can have multiple inputs, and based on that, you can have okay. So based on that input lines, you can have output, right? Where actually this is used, this is basically, 7418 PIC there, which is used for binary to octal, right? Binary to octal code, it actually decodes. Say suppose if it is 000, then this will be the output line which is active at that case, right? So this is simply, a decoder. So decoder is a circuit which contains an input line and an output line, right? The decoder is used to convert a code, right? Used to convert a code. So this is basically IC 74183 is used for binary to octal conversion, right? There is slight difference between demultiplexer and decoder, right? Decoder have multiple inputs. Demultiplexer have only one input, right? So that you should keep in your mind. Now next is implementation. Now from that you have a next question from multiplexer demultiplexer is by using this uh, multiplexer you can solve the Boolean function, right? Or implement your Boolean function by using multiplexer, right? So the question is like implement summation of m 4, 5, 7, 12, 13 using 4 as to 1 marks. Now, see, there are total 16 input lines, right? Present. Why? Because there are total 4 variables. So 4 select lines with 16 input lines are present. But in question, you'll have this thing. That means implement you need to implement given expression by using 4 as to 1 marks. For that reason, you basically need to reduce the given expression, right? What you need to do here is you need to reduce the given expression, all right? So first is, okay, so 0, 1, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 0. Okay, so this is how the expression works. Now, next and foremost thing here is select, you need to select the input lines, right? In that case, what input lines you are using or select lines you are using that you need to choose. Since there are 16 in 16 as to 1, total 4 select lines are present, and for 4 as to 1 there are 2 select lines are present. So from those 4 variables, we can use 2 variables as for select lines and 2 variables for input, right? 2 variables for select line and 2 variables for input. Now, if I consider CD as select line, right? If I consider CD as select line, then in this case, if I consider CD as select line, then that means you cannot use CD. So you need to identify expressions for this, right? For this is A complement B. Now here you can have group. In this case, not really 0 0 there. So B, that means C complement. No, sorry. We need to consider what we need to consider as select line. Since we are grouping in columns, we need to consider AB as select line, right? If I consider AB as select line, then the expression is, don't use AB. Now, C complement D. In this case, what is common? C is common. C complement, right? D is changing. So skip D. Don't use AB. Now for this group, right? This pair, which is common? D is common. So C complement or D is our second input. Then try for this one. Now, which is value is changing? D is value is changing. C is common. So C complement is there, and the next is C complement D as it is, right? So this is how you consider for your multiplexer. Those are select lines S0, S1 and S0 treated to be as A or BA, and those are input lines. Input lines are considered as C complement D, C complement plus D, C complement D. And this is your output, right? So this is how you can convert a 4 as to, 16 as to 1 marks into 4 as to 1 by to have the given Boolean expression into a real, right, existence. So this is how things comes in the Boolean expression. This is one way. Another way you treat it as C, again C complement C, C complement, and use this for input lines, right? So first is C complement D and pass it to here and so on, right? You consider this and pass it to इनपुट लाइन समझ लगा है कन्वर्ट कसं केलं? ओके. सो F A B C equal to okay. The expression using 1 as to 8 dmux realize करा using 1 as to 8 dmux realize करा. Okay, why we take AB as select line? अरे 4 variables, 4 variables होते A, B, C, D, right? हे 4 variables, 4 as to 1 mux मध्ये. पण in this case नो हे 4 select line होते, right? आणि हे 4 variable चे इनपुट आपल्याला द्यायचे. So if you are trying for 4 as to 1 नो, तुम्ही हे 4 व्हेरिएबल देऊ शकत नाहीत कारण इनपुट 4. सो त्या इनपुट लाईनला काय पाठवायचं आणि आउटपुट रादर सिलेक्ट लाईनला काय, तर ते कॉम्बिनेशन्स इम्पॉर्टंट आहेत, राईट? इकडून ए आणि बी चे कॉम्बिनेशन्स आणि इकडून सी आणि डी चे कॉम्बिनेशन्स तुम्ही पास करू शकता सिन्स दिस इज अ स्मॉलर बॉक्स, राईट? जर त्याचे कॉम्बिनेशन्स एक्झॅक्टली बघितले तर ते 16:1 साठीचे आहे, राईट? आणि तुम्हाला कन्वर्ट कशात करायचा आहे तो 4:1 मार्क्स. सो हे व्हेरिएबल सगळेच यूज व्हायला पाहिजे, राईट? याचे कॉम्बिनेशन्स इथं यूज होणारच आहेत. 0 1 1 1 1 0 1 1 1 आणि तसेच इकडनं कॉम्बिनेशन्स कुणाचे पास करायचे टीडेचे. फॉर दॅट रिझन आपण काय केलं ते रिड्यूस करताना कन्सिडर केले की 2 व्हेरिएबल्स त्याच्यातले सिलेक्ट लाईनला राहतील आणि बाकीचे 2 व्हेरिएबल इनपुट लाईनला राहतील. कळलं का?